Hi, today we're going to be starting 3 days worth of solving quadratic equations. And what we're going to do today is do it by one method called solving by factoring. All right, but before we do, let me give you some background. Number one, if 8 times a is 0, then what do you know about a? Well, we can solve for that. We could just divide the 8 over, and you're going to get 8 is 0. Number two, if 1 times 2 times 3 times 4 times a is 0, then what do we know about a? Now I could simplify and multiply the numbers and divide it over, or you can recall some old fact. If you're multiplying a bunch of numbers together and the outcome is 0, then if you recall, it means that at least one number in the group has to be a 0, because the only way to multiply and get a 0 is that you have to have a 0 in the numbers that you're multiplying. So since 1, 2, 3, and 4 are not 0, that only makes sense then that the a was the one that was a 0. Same thing with question 1. If 8 times a is 0, since 8 is not a 0, a had to be the 0. Okay, question 3. If a times b is 0, then what do you know about a or b? Well, I know that if I'm multiplying and get an answer of 0, at least one of the numbers is 0. But it could in fact be both of them. So I know that a could be a 0 or b could be also a 0. But I know that one or the other has to be a 0. All right, and that rule that we're using, that's called the zero product rule. And that rule just says that if you're multiplying and you have a 0 in the group that you're multiplying, the outcome is 0. Now that is what we're going to use to help us solve problem 4. Problem 4, we have to figure out what x squared number plus 6 times that number plus 8 makes a 0. Now I can sit here and guess, and I can guess 0. And that doesn't check out. I could guess 1. And that does not check out. And I could sit here all day, but I'm going to do something else. I'm going to factor what we did last time. I'm going to factor the quadratic, this side right here. And if I factor that, I have to multiply and get 8 and add up to get 6. And again, I can do this little trick because it's a trinomial that begins with a 1. So if I list out all my factors that make an 8, don't forget 2 negatives make a positive. I need to add up and get a 6. 2 and 4 are my numbers. And again, the trinomials that begin with a 1, 2 and 4 are going to end up being those 2 numbers in the factors. Okay, so here's what we're going to do. Question 3 actually shows us why what we're going to do works. And I'm going to highlight. This is A. This is our A. And then I'm going to color the B a different color. So I know if I'm multiplying 2 things together and the answer makes a 0, I know that one of the 2 pieces must have a 0 value. I don't know which one, so I'm going to set both of them equal to 0. One of these 2 has to be a 0. So now I have 2 little equations to solve. And we get 2 answers. There are going to be no rejects, so these should both check. If they don't, something is wrong with your algebra. But -2 and -4 are both x numbers that will make that be 0. All right, and that's our topic for today, solving quadratics by using the factoring method, which really is using the zero product rule. So problem number 1, if we want to solve that algebraically, one method that you can use is the factoring method. There are 2 other additional algebra techniques we're going to show you the next 2 lessons. Okay, so we're going to factor that. Again, this is our pretty trinomial. It begins with a 1. So all I have to do is figure out what multiplies to -40 and adds up to -3, excuse me. And if you recall, I can let my calculator do this. Again, you can do this by hand, but it's so much easier to use our algebra skills to our advantage. So I can put in negative 40 divided by x in my calculator. And then if I go to my table, I will get all the pairs of number that multiply to negative 40. I just get rid of all the bad ones. So I'm going to scroll my table, and I need to see which ones add up to negative 3. And right here, 5 times negative 8 is negative 40 when you multiply them, and it adds up to negative 3. So those are my factors. And then using the zero product rule, I know that if two guys are being multiplied together and they make a 0, one of the guys has a 0 value. So solving those two little mini sides, I get x is negative 5 and x is 8, and they will check out. Okay, now doing the alternative approach, because I always want you guys to be able to connect the math and also have backups. So the alternative approach is when you want to do graphic or table, you're going to go to your y equals. You put the left side of the equation in graph 1 and the right side of the equation in graph 2. And you make no changes before you do this. You just do it the way it's written. Now on the 84, a 0 line is hard to see. Not on the new color one, but on the old black and white. So you may want to go over to the end, and I already have done this. But if you press enter one time, it changes it from a thin line to a thick line. And I'll just cycle through it again so you can see it. So there's my thin line. If you press enter one more time, it changes it to a thick line. All right, so for your notes, you may want to write down what you did. There's graph 1, and there's graph 2. All right, so if you recall, I'm gonna say this strategy throughout the year. Visually speaking, an equation is where the two sides are equal to each other. So basically, it's where the two graphs intersect. Now, although you won't get full credit, this is a great way to double check your work or to get partial if this is the only way you can do it. You label your graph. You put down your first graph. Doesn't have to be accurate as long as it's close, and you label your second graph. And the points of intersections, the x values, are your answers. And you can count. That's a nice hit. It's definitely hitting at negative 5, 0. And it's definitely hitting at 8, 0. So your x values are your answers. X equals negative 5 or 8. The table of values method only works really nicely if the answers are whole numbers. If they're decimals, it's a little, you can still use your table, but it is a lot harder. You have to know what decimals to go by in your table. But if they're whole number answers, you do the same step. You do y1, y2, but now you go to your table. You're looking for where the y1 and y2 match. That means that they check out. And if you notice, they check out at 8. Now, I don't have to sit here and make an entire table connecting the two answers. I just have to make sure I show around 6 values in my table. So if 8 is an answer, I may want to show 7, 8, and 9 rows. And there's my one answer. And then I scroll to find the other one, which we know it's at negative 5, so I'll just go there. So there's my match again, and you just put it in your table again, 6 total rows. And then just make sure you state the answers. X is either equal to 8 or negative 5. Okay, on the 3 examples I'm about to show you, I'm just going to stick with the algebra method, but always just keep in mind these methods to have as a backup. Okay, so problem number 2. In order to use the zero product rule, which is what we're doing, you have to understand that we need a 0 as the outcome. So on problem example 2, you must get it in equals 0 form. And actually has to be in standard form as well. You want to be in highest to lowest power and equals 0 at the end. So on this problem, we'll have to subtract the 6 over. And then we're going to factor. And don't forget that you have all the different type of factoring. You have the GCF types, the dots types, the trinomials that begin with a 1, and the trinomials that begin with a 2, 3, etc. So this is another factoring where it begins with a 1. It's a trinomial. So we have to figure out what multiplies to make -6 and adds up to -5. Okay, those are all our ways to multiply and make -6. And the one that makes -5 is this one, 1 and -6. Okay, setting the both factors equal to 0. And those are our two answers. Problem number 2, it's already in equals 0 form. And if you notice, it doesn't even have 3 terms. So this is not our trinomials. Recall your factoring. I told you, always start with GCF first. If it's not GCF, it's dots if it has 2 terms with a minus, and then tries has 3 terms. So it's definitely not tries. So first off, we tried GCF. Is there something in common with those 2 terms? And there is. There's a 2 in common and an x in common. So this is a GCF type. We're going to pull out the 2x, and then we're going to have an x plus 8 left over. And that's it. There's nothing else we could do. If it's possible to refactor again, you would, because we need to break it down to all its factors. Okay, and now we have to solve for x. Well, recall that these 2 guys are being multiplied together. If 2 are being multiplied together and they make a 0, one of the 2 sides has to be a 0. So one of those 2 have to have a 0 value. All right, on the left, we're going to divide out the 2. Be careful not to subtract the 2. That's a common mistake. And then on the right-hand side, we're going to subtract the 8 over. And -8 and 0 are your answers. Okay, and finally, example 4. Definitely can't do anything with it now. I want to use the 0 product rule, which means I need an equal 0. So bringing the 2x over by subtracting. And then bringing the 20 over. And you could do that all in one step if you prefer. Okay, so now I have to see how to factor this. If I look at all the terms do not have a common GCF in it. So it's not a GCF type, and it's not a dots type, so it's a try. But these are the ones that begin with a 2. If you recall from last class, you cannot just simply multiply to make -20 and add up to 3. It won't work that way. So I'm going to use that AC method. That's where you multiply the 2 and the last 2 terms, the A term 2 and the C term -20. And we multiply those together. And then we figure out all the factors of -40 that add up to 3. But we're not using the 20, we're using the -40. So I'm going to let my calculator do that. So -40 divided by what x number? All right, going to my table, I got to figure out which one adds up to +3. And -5 and 8 multiply to -40, and they add up to 3. Okay, so if you recall, the ones that begin with a trinomial that begins with a 2, we don't just simply put the -5 and the 8 in parentheses. We do what's called I call split the middle. So we keep the 2x squared term, we keep the negative 20 term, but we're just going to split the middle so that it makes, we're going to use the negative 5 and the 8 to say negative 5x plus 8x. Then you do the GCF of the two groups. In the first group, the only GCF there is an x. Pull out the x, you get 2x minus 5 inside. In the right-hand group, you always have to have a sign here. The first term is what dictates the sign. If that's positive, then the term out here will be positive. And there is a 4 in common with 8x and 20. So pull out the 4, and then you have a 2x and a minus 5 left over. And if you do this properly, then you're going to have two matching parentheses, and those two indicate that there is a GCF. So these and these match. So what happens now is we're going to pull the 2x minus 5 out, and the two leftover pieces come together. So there's our factored form. And once I factor, now I can use the zero product rule. I know that if two guys are being multiplied together, they make a 0. One of them is a 0 value. You can leave 5 halves as the answer, or you can make it 2.5 since it is a nice decimal. And those are your two answers. They will both check out. So all of this lesson today is dependent upon your factoring ability. You have to have factor everything, and if you can't factor, then that's just going to be the issue on today's lesson.